Hello, good morning, students. Today I am going to start the lecture number 15 of your kinetics special paper. And in the last lecture, we have studied about uncompetitive inhibition. And in this topic, we have studied that primary plot between 1 upon R and 1 upon S gives straight line at different but fixed concentration of inhibitors. 1 upon R is rate and S concentration is substrate concentration. This plot is a primary plot of uncompetitive inhibition and is considered to be the exceptional characteristic for identification. In this case, we get only intercept effect but not the slope effect. This helps in distinguish uncompetitive inhibition from those of competitive and non-competitive inhibition. Primary plot you can see in the diagram is straight line and it has different concentrations. Substrate concentration is different for the three lines. Okay. Now we will study the rate equation for competitive inhibition. In both the enzyme and enzyme substrate complex bind inhibitors, the following model results. Both enzymes and enzyme substrate complex, they complex together to bind inhibitors. This following model will result. First here E is enzyme and S is substrate. With a rate constant of K1, a forward reaction, and K2, a reversible reaction, a complex ES is formed. This ES is rate constant. This complex is rate constant K3 can be converted into product and enzyme is regenerated. In the second form, this E and S, it combines with I inhibitor with a rate constant of Ki and it forms EI complex. Similarly, enzyme E substrate complex ES can react with Ki with I with a rate constant of Ki dash and form a complex ESI. Okay. Then this EI complex form with reversible reaction depending upon the substrate concentration is converted into ESI or converted into EI, and ESI gives no reaction. Both of inhibitor binding steps are assumed to be at equilibrium but with different dissociation constants. कौन से हैं inhibitor binding steps? This is rate constant K1, Ki and with Ki dash. These both inhibitor binding steps are assumed to be at equilibrium. देखो बीच में equilibrium का साइन है बट विद डिफरेंट डिसोसिएशन कांस्टेंट दोनों के डिफरेंट हो सकते हैं, इसीलिए हमने यहाँ पर Ki और Ki dash लिखा. Now Ki is equal to concentration of E into concentration of I divided by concentration of complex EI. This is equation number 1. Or we can write EI is equal to E concentration of E into concentration of I divided by rate constant Ki. Similarly, K dash I we can write as ES concentration into I concentration gives ESI number 2. The phenomenon is alternating, called as mixed inhibition or non-competitive inhibition. The conservation condition for this relation scheme is given by Et is equal to concentration of E plus concentration of EI complex plus concentration of ES complex plus concentration of ESI complex 3. This is conservation condition. Put the value of 1, 2 and 3 in equation. If we put the value of 1, 2 and 3, 1 से हम लेंगे EI की concentration, ठीक है, बाकी फिर हम 3 से लेंगे 2 से लेंगे ESI की concentration और ES की concentration हम लेंगे K1 से ऊपर के डायग्राम से. So Et is equal to E bracket close 1 plus I concentration upon Ki bracket close plus ES concentration bracket out of bracket common and inside the bracket there is 1 plus I upon K1I. This is equation number 4. Or we can write Et is equal to E अल्फा हमने पहले भी लिखा है प्लस ई एस अल्फा डैश. This alpha or alpha dash alpha is equal to 1 plus I concentration upon Ki is alpha and 1 plus I upon Ki dash concentration is K alpha Es into alpha 1 dash. This is equation number. Here alpha is equal to 1 plus I concentration upon Ki and alpha dash is equal to 1 plus I concentration upon any steady state condition for Es. We get d by dt of Es is equal to K1 into concentration of E into concentration of S minus K2 into concentration of Es minus K3 into concentration of Es, and this is equal to 0. Steady state concept apply किया है Es के concentration पर. Now we can write K1 into concentration of E into concentration of S is equal to Es is a common thing, and K2 K3 both are we are joining inside, so we are removing this minus sign, so it comes out to be K2 plus K3, and this is equal to 0, or this is equal to K1 Es. Now from this, E concentration is equal to K2 plus K3 into E concentration into SES complex concentration upon K1 into concentration of substrate. Now we can write E is equal to K2 K3 upon K1 ES concentration into substrate concentration. This equation is divided by K1. Now E is equal to K1 K2 K3 upon K1. You know that it is Michaelis-Menten constant. So we have converted into in order to convert into Km, we have divided equation by K1. So it is equal to Km into concentration of Es upon concentration of S. This is equation number 6. From equation 5 and 6, put the value of E and take common. From equation 5 and 6, 6 कौन सी है? E वाली है. इक्वेशन नंबर 5 हमारी है सेकंड पेज पर. E सबस्क्रिप्ट T is equal to E L concentration alpha plus ES concentration alpha dash. If we put these equations 5 and 6 and put value of E and take common, then ET is equal to ES alpha Km upon S plus alpha dash. This is equation number 7. As we know that rate is equal to K2 into ES. So R is equal to K2 into ES कहाँ से आया? अब ये ऊपर से 7 से आएगा. ET into concentration of S upon Km plus alpha dash S. Then defining K2 into ET is equal to R maximum. So rate is equal to R maximum upon into S concentration divided by alpha Km plus alpha dash S. The Line-Weaver-Burke equation or double reciprocal equation of the mixed inhibitor is given by 1 upon R. Is given by 1 upon R. Wait a minute, बच्चों. The Line-Weaver-Burke equation or double reciprocal equation for mixed inhibitors is given by 1 upon R alpha maximum upon R maximum into 1 upon substrate concentration plus alpha 1 into R divided by R maximum. This is equation number 9. It is seen from equation 8 that the denominator has the factor alpha. नीचे आ रहा है, denominator means नीचे. ठीक है? Seen from equation that the denominator has the factor alpha multiplying Km as in competitive inhibitors. Km से अल्फा को मल्टीप्लाई किया है इक्वेशन 8 में as in competitive inhibitors and factor alpha dash multiplying with S as in uncompetitive inhibitions. Now rate equation for uncompetitive inhibition. Inhibitor binds directly to the enzyme substrate In this, inhibitor binds directly to the enzyme substrate complex but not to full enzyme such that E plus S with rate constant K1 and K2 is converted into ES complex. With rate constant K3, it is converted into product plus enzyme regenerated. Now this ES complex combines with inhibitor with rate constants of K1 dash and is form ESI. सेकेंड जो है कोर्स है विद रेट कॉम्बिनेशन विद I with rate constant Ki is not occurring here. So ESI will give no reaction. The dissociation constant for inhibitor binding step is equal to Ki dash is equal to ES into I concentration divided by ESI concentration. This is number 1. The conversion condition ET is equal to E plus ES plus ESI is equal to equation number 2. Under steady state condition of E into S complex concentration, d by dt of ES is equal to Ki concentration of E, concentration of S minus K2, concentration of ES minus K3 into concentration of ES is equal to 0, or E is equal to Km ES upon S. From equation 1, 2 and 3, we get Et is equal to ES Km upon substrate concentration plus bracket में 1 plus I upon K dash into I concentration, equation number 4, where alpha dash is equal to 1 plus I upon K1I. Et is equal to ES concentration, in bracket there is Km and substrate concentration plus alpha dash. This is equation number 5. Now ES concentration is equal to Et concentration at T time and S concentration divided by Km plus alpha into substrate concentration, equation number 6. According to rate equation, rate is equal to K2 into ES. This is equation number 7. From equation 7 and 6, R is equal to K2 Et S concentration upon Km plus alpha dash S concentration. K2 into E at T subscript is equal to R maximum divided by S concentration. So R comes out to be R maximum upon Km upon S concentration plus alpha dash. Upon arrangement gives Michaelis-Menten equation for uncompetitive inhibition, and this R is equal to R maximum into S concentration upon Km plus alpha dash into S. This is equation number 9. Interpretation of this equation indicates that high value of concentration S R asymptotically approaches to R maximum upon alpha dash, so that क्या है high values of S concentration R asymptotically approaches to R maximum upon alpha dash. Solution. In contrast to competitive inhibitions on R maximum are not reversed by increasing the substrate concentration. At low substrate concentration, that is substrate concentration is low than Km, effect of one uncompetitive inhibition become negligible. Again, the opposite behavior of competitive inhibition. Next है double reciprocal form of equation 9 is 1 upon R is equal to Km upon R maximum concentration 1 upon S substrate concentration plus alpha dash upon R maximum, equation number 7. With this we are completing second unit where we have studied about the kinetics of inhibition. Thank you. We will start new topic later on.